Okay, example 5. A car travels on a straight track. During the time from 0 to 60, the car's velocity measured in feet per second is a continuous function. All right, we're told that. Okay, and we're told that. So the table below shows selected values of the function. Okay, so part A for 0 less than t less than 60. Is there a time where t must be where t must be a time t where v of t is equal to -5? Well, I can see it. It's happening between these two now. So really, I could just say between 35 and 50 because that's on the interval we're talking about. So that's what I'm going to do. I know that between 35 seconds and 50 seconds, we went from driving backwards. It's driving backwards, y'all. The velocity is negative, and then it stopped. All right. So if it went from driving backwards at -10 feet per second to stopping, then at some point in between those two it had to be -5. But let's justify it using the intermediate value theorem. All right. So here we go. Again, I think I'll write it. Okay. So number one. All right. So number one, we're told that v of t is a continuous function. Okay. Everywhere. Okay. So we're told that. So that's good. And then number two, we know that v of 35 is equal to -10, and v of 50 is equal to 0, and they're not equal to each other. And so v of 35 is not equal to v of 50. So this means that the intermediate value theorem applies. So I can say then by intermediate value theorem, okay, there is a time t where v of t is equal to -5, okay, on the interval 35 to 50. Okay. Oh, and then we could add since, probably a good idea. This is true. -10 is less than, -5 is less than 0. It's in between. Okay. Maybe should have said something about that on these up here also. Like right here, if you want to go ahead and add it, you could. Since -1 is less than 0 is less than 2. All right. Since that. And probably on that one too. Since -1 is less than 1 is less than 29. It might be good to add those in there real quick. Okay. All right. We'll do 6 and 7 in just a second.